Fasten your seatbelts. We're taxiing down the runway and about ready to take off. We're fixing to climb.
And away we go!
Number 10. Hypervelocity stars. Everyone knows that shooting stars are just meteors entering the atmosphere, right? That was kind of funny. What some people don't know, however, is that real shooting stars exist as well. They're called hypervelocity stars. These big fiery balls of gas rocketing through space at millions of miles per hour. When a binary star system at the center of a galaxy, one of the two partners is consumed, while the other is ejected at high speed. Just try to imagine a huge ball of gas, 4 times the size of our sun, hurtling out from our galaxy at millions of miles per hour. Number 9. The planet from hell, Gliese 581c. Scientists have determined that this hell of a planet is the most likely candidate for future colonization, despite the fact the entire planet wants to kill you. This planet orbits a red dwarf star many times smaller than our Sun, with a luminosity of only 1.3% of our Sun. This means the planet is far closer to its star than we are to ours. Because of this, it is stuck in a state of tidal locking, meaning that one side of the planet is always facing the star, and the other side is always facing away, just like our moon's relationship with Earth. Not quite. The moon and Earth are in sync so well that we never see a different side of it. That's how I understand that. The tidal locking of the planet alone results in some pretty odd features. Stepping out into the star side of the planet, it would immediately melt your face off, whereas standing in the opposite side of the planet, where there is no sun, would freeze you instantly. However, in between the extremes is a small belt where life could theoretically exist. Living on Gliese 581c would have its challenges, though. The star it orbits is a red dwarf, which means that it is at the lower frequency end of our visible spectrum, bathing the entire sky of Gliese 581c in a hellish red color. Another side effect of this is the fact that photosynthesizing plants would have to adapt to the constant bombardment of infrared radiation, rendering them a deep black color. Well, Earth used to go around a red or brown dwarf. That is probably why infrared light is good for you. Just looking at this right here, increases energy, makes your skin healthier, gets rid of cellulite, speeds up fat loss, improves muscle recovery, improves mood, cognitive functions, speed healing from injury, and improves metabolism and hormonal health. That's just that one. I've seen others. There must be something natural about it. There's all kinds of things that is good about infrared light. That wouldn't just be by chance that that is the case. There is a theory that says that actually what killed the dinosaurs off was flowering plants. And the gravity change, of course. Once the sun got involved, it changed all the plants, and the ones that the dinosaurs were eating went extinct, and then naturally they went extinct after. Many dinosaurs lived in the Purple Dawn era. That's why they have the big eyes and why they could grow to such ridiculous sizes. But dinosaurs weren't the only ones that got to grow to giant sizes. Humans did too. The gravity seemed to be changing a lot at one time or another. Or it would go for a while and then change again and then change again. I would think it's done changing now, but you never know. That's an interesting thought. Dinosaurs that are known as meat eaters on a meteor. So they were nocturnal. It isn't just for nothing that we have nocturnal creatures. Something had to bring that about. Number 8, the Castor system. Here we have the Castor system as one of the 2 bright stars from the Gemini constellation in our night sky. It has some serious luminosity. This is because the Castor system isn't 1 or 2, but 6 stars, all orbiting around a common central mass. 3 binary star systems orbit each other here. So much for a trinary system being rare, they're probably common too. With 2 hot and bright A-type stars being stuck in the system, as well as 4 M-type red dwarfs. Altogether, though, these 6 stars put out roughly 52.4 times more luminosity than that of our Sun. Alright, quiz time. What type of star is the Sun? Okay, time's up. Is it a class M star, a class A star, a class G star? Answer at the end of the show. It's a class G star. Number 7. Space raspberries and rum. Let's see what it says. For the last few years, scientists have been studying a dust cloud near the center of our Milky Way galaxy. If there's a God out there, it seems that he decided to get creative. This dust cloud, plasma, named Sagittarius B2, smells of rum and tastes like raspberries. And how would they know that? The gas cloud in question consists largely of ethyl formate, which is known to give raspberries their taste. I see, said the blind man. And rum its distinctive smell. Arr! The large cloud is said to contain a billion liters of the stuff, which would be great if it wasn't rendered undrinkable by a pesky particle like propyl cyanide. The creation and distribution of these more complex molecules is still a mystery to scientists, however, so we won't be opening up an intergalactic pub anytime soon. Which reminds me, did you know that the electric force is 1,000 billion times more powerful than gravity, or 10 to the order of 39? Number 6 is a planet of burning ice. I've heard about this one before. Do you remember Gliese, that hellhole of a star that we visited earlier? We're heading back to the same solar system for this one. Gliese supports a planet made almost entirely out of ice. At 439 degrees Celsius, Gliese 436b is quite simply a burning ice cube. Imagine Hoth from Star Wars. I don't want. Except that it's on fire. The only reason this ice stays solid is because of the huge amount of water present on the planet. The gravity pulls it all in towards the core, keeping the water molecules so densely packed that they cannot evaporate. Number 5, the Diamond Star. 55... oh boy.
Cancri.
Made entirely out of crystallized diamond. Would be priced at $26.9 million. Okay. The huge diamond planet was once a star in a binary system, until its partner began to cannibalize it. However, the star was not able to pull its carbon core away, and carbon is just a ton of heat and pressure away from being a diamond. So at the surface temperature of 1648 degrees Celsius, the conditions are almost perfect. 1/3 of the mass of the planet is said to be pure diamond, whereas Earth is covered in water and abundant in oxygen. This planet is made mainly of graphite diamond, and a few other silicates. The huge gemstone is 2 times the size of Earth and has 8 times the mass, making it a super Earth.
And now for a word from the electric universe. Rawr.
Is the universe expanding? Maybe not. This is from July 20, 2020. Stars are mainly composed of hydrogen. According to consensus ideas, nuclear reactions are thought to convert that hydrogen into helium, initiating the energetic emission that make life on Earth possible. When temperatures in average stellar cores reach about 100 million Kelvin, helium's kinetic energy is strong enough to overcome electrostatic repulsion. So it fuses into carbon-12 and a so-called triple alpha process. After carbon-12, other exotic fusion reactions are said to occur as a star ages, until finally it reaches a stage where nickel-62 nuclei begin to accumulate. Nickel-62 has the highest binding energy per nucleon of any elements, so it can no longer be fused into heavier elements no matter how hot a star's core might become. The accumulation of this heavy ash essentially halts fusion, so radiative pressure is no longer able to hold back the force of gravity that always wants to crush the star. Suddenly, the star's outer layers catastrophically collapse, rebounding off the core out into space in what astronomers call a supernova explosion. In 1997, Adam Rees and Saul Perlmutter were studying Type 1a supernovae because their rise in luminosity and their subsequent decline are considered predictable in consensus circles. That measurement is a way of determining a supernova's true brightness. By calculating the supernova's redshift, they can place it in space-time coordinates and find out how far away it is. When Rees and Perlmutter crunched the numbers from their observations, they were shocked to discover the recessional velocity redshift of the most distant Type 1a supernova indicated that they were accelerating. And not only that, the further away they were, the faster they were speeding up. This effect is called dark energy, because no apparent cosmic influence could be seen. As time went on, new observations by various groups resulted in the conclusion that dark energy makes up 75% of the universe. Dark energy is another of the phantoms that arise when redshift is applied to observations. Redshift has been the bane of astrophysics since Hubble first identified what he thought was the Doppler effect in images of faint galaxies. Instead of seeing redshift as an effect of acceleration and distance, it may be an intrinsic property of matter. Astronomer Halton Arp proposed that idea many years ago, and it deserves further investigation, especially when anomalous observations are considered. High redshift objects in front of low redshift objects, for example. All of the dark things in astronomy are artifacts of a crackpot model of cosmology, and we're going to be doing a little spotlight on Halton Arp's discovery in a little bit. The dark energy model of the universe demands that eventually all of the stars will disappear, and there will be eternal darkness. In the words of Brian Schmidt, the future of the universe looks very bleak. I think the future for him is bleak. He confirms my portrayal of Big Bang cosmology as hopeless. Wal Thornhill. All right. And then it says Steve Smith, so they must have both wrote this. I gloomily came to the ironic conclusion that if you take a highly intelligent person and give them the best possible elite education, then you will most likely wind up with an academic who is completely impervious to reality. Halton Arp. Seeing Red by Halton Arp. There is now a fashionable set of beliefs regarding the workings of the universe, greatly publicized as the Big Bang, which I believe is wildly incorrect. But in order to enable people to make their own judgments about this question, we need to examine a large number of observations. Observations in science are the primary and final authority. More than 10 years have passed, and in spite of determined opposition, I believe the observational evidence has become overwhelming, and the Big Bang has in reality been toppled. There is now a need to communicate the new observations. the connections between objects, and the new insights into the workings of the universe, all the primary obligations of academic science, which has generally tried to suppress or ignore such dissident information. It makes one wonder with profit whether there are other uncertain assumptions on which much of our lives are built, but of which we are incorrectly overconfident. The present book is sure to outrage many academic scientists. Many of my professional friends will be greatly pained. Why then do I write it? First, everyone has to tell the truth as they see it, especially about important things, integrity. The fact that the majority of professionals are intolerant of even opinions which are discordant makes change a necessity. Those friends of mine who also struggle to get the mainstream of astronomy back on track must feel that presenting evidence and championing new theories is sufficient to cause change, and that it is improper to criticize an enterprise to which they belong and value highly. I disagree. In that I think if we do not understand why science is failing to self-correct, it will not be possible to fix it. At this point, I believe we must look for salvation from the non-specialists, amateurs, and interdisciplinary thinkers, those who form judgments on the general thrust of the evidence, those who are skeptical about any explanation, particularly official ones, and above all, are tolerant of other people's theories. When the complete answer is not known, in a sense, everyone is a crackpot. Gasp. If the cause of these redshifts is misunderstood, then distances can be wrong by factors of 10 to 100, and luminosities and masses will be wrong by factors up to 10,000. We would have a totally erroneous picture of extragalactic space, and be faced with one of the most embarrassing boondoggles of our intellectual history. Because objects in motion in the laboratory, or orbiting double stars, or rotating galaxies, all show Doppler redshifts to longer wavelengths when they are receding, it has been assumed throughout astronomy that redshifts always and only mean recession velocity. No direct verification of this assumption is possible, and through the years, many contradictions have arisen and been ignored. The evidence presented here is, I hope, convincing because it offers many different proofs of intrinsic non-velocity redshifts in every category of celestial object. It is interesting to note that at first Einstein felt the solution was incorrect. Later, he said it was correct, but of no consequence. Finally, he accepted the validity of this solution, but was so unhappy with the fact that it was not a stable solution, i.e., it either collapsed or expanded, that he retained the cosmological constant he had earlier introduced in order to keep the universe static. This constant was later referred to as the cosmological fudge factor. In 1924, Hubble persuaded the world that the white nebula were really extragalactic, and a few years later announced that the redshifts of their spectral lines increased as they became fainter. This redshift apparent magnitude relation for galaxies became known as the Hubble law, through lack of rigor often referred to as the redshift distance relation. At this point, Einstein dropped his cosmological constant as a great mistake and adopted the view that his equations had been telling him all along, that the universe was expanding. Thus was born the Big Bang theory, according to which the entire universe was created instantaneously out of nothing 15 billion years ago. This reality is the entirety of the theory on which our whole concept of cosmology has been rested for the last 75 years. It is interesting to note, however, that Hubble, the observer, even up to his final lecture before the Royal Society, always held open the possibility that the redshift did not mean velocity of recession, but might be caused by something else. In his seminal book, Realm of the Nebula, Hubble wrote, "On the other hand, if the interpretation as velocity shifts is abandoned, we find in the redshifts a hitherto unrecognized principle, whose implications are unknown. In the ensuing years, the evidence discussed in the present book has built up to the point where it is clear that the velocity interpretation can now be abandoned in favor of a new principle which stands on a firm observational and theoretical foundation. But of course, the stunning aspect of the Rosette observations was that two quasars of redshift 0.63 and 0.45 are actually physically linked by a luminous connection to a low redshift object of z equals 007. When I showed this to the local experts, they were alarmed. There were alarmed states followed by annoyance. This result made it clear that the compact and interacting groups were just a more concentrated assemble of young, non-equilibrium companion galaxies, which had been ejected more recently from the parent galaxy, and were composed of material of higher redshift. Aside from being empirically true, this interpretation solves all the conventional paradoxes of the failure of the galaxies to merge into a single galaxy on a cosmic timescale, and also explains the unbearable presence of discordant redshifts. In later chapters, do not evolve with smoothly decreasing redshifts, but change in steps. One major point of the present book is to try to make it impossible to ignore the enormous amount of mutually supporting significant evidence, which all points to the same conclusion. In the face of 28 years of accumulated evidence, to go on proclaiming that quasars are out at the edge of the universe seems unpardonable. Halton Arp. Here is a list: summary alignments quasars, galaxy clusters. Objects which appear young are aligned on either side of eruptive objects. This implies ejection of protogalaxies. 2. The youngest objects appear to have the highest redshifts. This implies that intrinsic redshift decreases as the object ages. 3. As distances from the ejecting central object increases, the quasars increase in brightness and decrease in redshift. This implies that the ejected objects evolve as they travel outward. 4. At about z equals 0.3 and about 400 kpc from that parent galaxy, the quasars appear to become very bright in optical and X-ray luminosity. This implies that there is a transition from BL-LAC objects. There is a transition to BL-LAC objects. Few BL-LAC objects are observed, implying this phase is short-lived. Clusters of galaxies, many of which are strong X-ray sources, end to appear at comparable distances to the BL-LACs from the parent galaxy. This suggests the clusters may be a result of the breaking up of a BL-LAC. 7. Clusters of galaxies in the range of z equals 0.4 to 0.2 contain blue active galaxies. This is implied that they continue to evolve to higher luminosity and lower redshift. 8. Able clusters from z equals 0.01 to 0.2 lie along the ejection lines from galaxies like Sin A. Presumably, they are evolved product of the ejections. 9. The strings of galaxies which are aligned through the brightest nearby spirals have redshifts z equals 0.01 to 0.2. Presumably, they are the last evolutionary stage of the ejected protogalaxies before they become slightly higher redshift companions of the original ejected galaxies. Okay, Thunderbolts does have one for diamond stars. The diamond fields of the mind. A planet made of compressed carbon is said to be orbiting a neutron star. The star becomes a diamond. A recent press release announced the discovery of a planet in orbit around a pulsar that is thought to have once been a star, but is now a planetary body composed of something similar to compressed carbon or diamond. The reason for the supposed density and composition assumptions is that the planet was seen in an orbit around the pulsar that is deemed impossible to consensus astrophysics. As announced by the Max Planck Institute for Radio Astronomy in Bonn, Germany, pulsar 1719-1438 rotates more than 10,000 times per minute, has a mass about 1.4 times that of our Sun, but is only 20 kilometers in radius. What is it about the planet's orbit that causes the assumption it is crystalline and dense? Pulsars are neutron stars as the second link. As the theory posits, a neutron star comes into being when a star with at least 5 times the mass of the Sun implodes, shredding its outer layers in a supernova. Since the star is no longer able to shield itself against its own immense gravity, with thermonuclear fusion theory, gravitational acceleration theory takes over, pulling all the electrons in the remaining stellar matter into the nuclei. 2 more links. The massive star's original angular momentum remains, so its rotational period can be astonishing. As 1719-1438 attests, the increase in rotational velocity can be likened to an ice skater's arms stretched out in a slow spin and then pulled in tight, thus increasing the spin rate. Another link. The force is generated when trillions of gigatons spin as fast as a dentist's drill, means that the star ought to burst apart like a cracked flywheel. However, enough mass is added to the theory so that gravity can hold it together, of course. There is thought to be an immense magnetic field surrounding the pulsar that is focused at each pole. Narrow beams of radio waves blast out from the polar cusps, like lighthouse beacons. Whenever the beam intersects Earth, telescopes fitted with gamma-ray radio wave or X-ray detectors can see it. The final theoretical link in the pulsar chain of circumstances is the tidal force theory that would tear apart a companion star or planet if it came too close. Before discussing the nature of the planet in orbit around the pulsar, it should be pointed out that there was no observation of the pulsar. Rather, researchers first found it in 200,000 gigabytes of data obtained from 3 different radio telescopes, analyzed by supercomputers at 3 different computation centers, using customized software. Garbage in, garbage out. Since 1719-1438's pulses and the data were seen to be systematically modulated, the only conclusion their computer models could reach is that a companion planet is in orbit around the pulsar. Astronomers think an original stellar companion gave up most of its material to the pulsar. As theory supposes, this results in a millisecond pulsar with a white dwarf companion. When I think of pulsars, I remember Don Scott's piece on Thunderbolts of the Gods, which was very enlightening indeed. That was just amazing. He made me think of a strobe light, a relaxation oscillator. Who didn't have one in the 70s? That is what controls a strobe light. So it's the same exact thing, probably, just on a much grander scale. Astronomers think an original stellar companion gave up most of its material to the pulsar. As theory supposes, this results in a millisecond pulsar with a white dwarf companion. 1719-1438 and its dwarf partner are thought to be close together. So the companion must be a white dwarf that has lost 99.9% of its original substance, leaving behind what astronomers suggest is a planet-sized carbon and oxygen sphere. Any lighter element constituents would mean the star would be too big to fit the measured orbiting times. Another possibility, one not considered by contemporary astrophysics, is that electrical oscillations are causing the rapid flicker of pulsars. Don Scott, in his book The Electric Sky, stresses that neutron stars are impossible phantoms, suggesting instead that there is an electrical explanation for their periodic pulses. He proposes that pulsars are relaxation oscillators. Their pulse frequencies are not mechanical. Instead, it is the capacitive, resistive, and inductive electrical environment around the star. Compacted matter and extreme rotation are not necessary. Electricity traveling through circuits provides a coherent explanation that is consistent with commonly accepted electromagnetic theories, as well as with laboratory experiment. That's the wonderful thing. Electricity and plasma, you can have tiny little experiments, and you can just keep going out to massive galaxies. That is wonderful. When the focus shifts from gravity and gas toward the electrical behavior of an entire system, then steps can be taken that will help to quantify the absolute current density in that system, as well as the capacitive and resistive values, and the magnetic fields generated by the inductive interaction of the binary pair. There must be an electric current generating the immense magnetic fields in a pulsar. It is also indisputable that the feeder current must be part of a circuit, since persistent electric current must complete a circuit. That circuit includes the galaxy in which stars reside, along with all the other galaxies associated with their clusters. Pulsar oscillations are most likely complex in their origins. Steve Smith. Indeed, yes. And that, it's just impossible that they recently found 10 to the 18th amps raw electric current in space, and it doesn't faze them. I just don't get it. Well, I do, but what that comes with is I don't want to believe. It's mind-boggling to me. It's got to be more like they're not allowed to. Couldn't find anything else from the top 10. And back to the top 10. Number 4. The Himiko Cloud. If there has ever been any object that has shown us origins of a primordial galaxy, this is it. The Himiko Cloud. The Himiko Cloud is the most massive object ever found in the early universe, and it dates to only 800 million years after the Big Bang. Oh, man, close. The Himiko Cloud astounds scientists with its sheer size, roughly half that of our Milky Way galaxy. Himiko belongs to what is known as the reionization, an electrical term, or the period from around 200 million to 1 billion years after the Big Bang. It's the first glimpse scientists have managed to get of the early formation of galaxies. To make it even cooler, it has been introduced as the giant mystery blob discovered near the dawn of time by Space.com. The Himiko Cloud, huh? It's interesting. And number 3, the universe's largest water reservoir. 12 billion light years away, the universe's largest water reservoir resides in the heart of a quasar, containing 140 trillion times the amount of water in Earth's ocean, and found near the colossal black hole at the center of the quasar. The water, unfortunately, manifests itself in the form of a massive cloud of gas. Just, wow, 1,000 trillion tons! Not to keep harping on Thunderbolts of the Gods, but there's a spot in there where a gentleman, I don't know his name, but he says that astronomers are looking through the wrong end of the telescope and describing what they imagine they see. I think that is a very good way to sum it up. Number 2, the universe's largest electrical current. And I kid you not, I was just mentioning this. Only a few years ago, scientists stumbled upon an electrical current of cosmic proportions. 10 to the 18th amps, or roughly 1 trillion lightning bolts. What kind of power? The lightning is thought to originate from an enormous black hole, of course it does, in the center of the galaxy, which has a core that is supposedly a huge cosmic jet that sprays big bubbles. Apparently, the black hole's huge magnetic field allows it to fire up this lightning bolt through gas and dust It's over 150,000 light years away. And we thought that our galaxy was big. This single lightning bolt is 1.5 times the size of the Milky Way. Sorry, but we'll get to it. The number 1, the LQG. This is the last one. This is the number 1 surprising thing in space. Now, you know, of course, going back to the quasars for a minute, Halton Arp proved that they're attached to Seyfert galaxy, which I have a spot coming up on later. So, yeah, the Hicamo cloud is pretty big, like half the size of our galaxy. What about a structure in space so enormous that it breaks the conventional laws of modern astronomy? The structure, my friends, is the LQG, the Large Quasar Group. Our galaxy, the Milky Way, is only 100,000 light years across. Think about that for a moment. If something happens on the far side of the galaxy, it would take 100,000 years for the light to reach the opposite end. I mean, they don't even really think about that. How could a galaxy function if it was 100,000 years behind itself? Just like with the Earth and the Sun. How could the Earth orbit the Sun where it was 8 minutes ago? That right there kills the standard model, but they just ignore it and keep moving. That means something's just basically wrong with that whole thing, and it always has sounded wrong. Now take the length of time and multiply it by 40,000. That's right. The Large Quasar Group is 4 billion light years across. The cluster of 74 quasars actually breaks the rules of standard astrophysics, since the maximum size of any cosmic structure should be only 1.2 billion light years across. What comes to mind with that is something I've heard before. They're looking at a bird 20 feet away from them and imagining 747s on the horizon. Something to that effect. Scientists have absolutely no idea how this huge structure formed, since they had previously only been aware of other clusters of perhaps several 100 million light years across. The gargantuan structure absolutely spits on a certain physical law, which states that when viewed from a distance, the universe would look relatively uniform. This is exactly the type of condescending cosmic structure that looks over at our galaxy and, with a smirk, says cute. Interesting article.
This is not a drill.
You know, many people say Hubble's discovery of the redshift was the most important discovery in the history of cosmology. I have to beg to differ with that, as I'm sure you will too, when you know all of the facts. That's one thing. When you're researching, you really have to learn all the facts. It's hard sometimes because they keep them hidden and suppressed. You're not going to find them on the surface, on, TV or any, like, History Channel or anything like that. They just won't go there. But they never talk about electricity. And that's something that always bugged me, so that I knew that electricity was this immense power that existed in the universe. And I just try to think where we'd be without it. I doubt we'd even be here. But this whole thing with redshift was disproved by Halton Arp in 1966. And instead of investigating the evidence, they tried to sweep it under the rug. I mean, the mathematicians, as I understand it, took Einstein's equations and ran with them. And Einstein tried to put in, what was it called? The cosmological constant. But he ended up taking it out, thinking it was a mistake. So I have a little something here from Halton Arp. First, this clip of what I think is at least one of the most important discoveries in the history of the universe by Halton Arp. That is vitally important information. If you've seen it before, it's always good to get a refresher. I know that I've shown clips from this video before, and at the risk of you getting maybe tired of it, I see it as one of the most important documentaries to be seen by people, because this is completely apart from the electric universe part of it. And let's face it, it's an eye-opener when you see just how academia conducts themselves when challenged by a new discovery. I mean, that should be expected in science. And doing science by consensus or peer review is just, I don't know, moronic and lazy. So even if they don't agree with that, it's just, to me, a very stark image of what academia is really like. And when people see that, like it did for me, it's going to turn them off. I know Halton Arp has high hopes here, and eventually he's going to be right. The only thing is, it could take another 100 years, but I doubt it. More data comes in, that one discovery is going to put it over the top, and it's not going to be maybe another decade. That's how I see it. I could be wrong. Once one looks at the evidence, it doesn't take long to see that the electric universe, if you watch a video or read an article from Thunderbolts, or if you watch this video, or Don Scott, or Wall, or any of those guys, or from the plasma universe that this is a part of, you get cold, hard scientific facts and data, information. When you watch a mainstream video, or even read a mainstream article, you just get filled with a bunch of meaningless chatter, like Saturn could float if it could fit in a bathtub. Things like that don't mean anything. Black holes do the human race absolutely nothing. It's a way for them to trick people by making them think it's over their heads. It's really not. That's a scam. That's a trickster's game. That's how I see them now. They're not that dumb. And then you get the gas bags that are they're in love with their own voice and they believe their own image. Hidden. These people, it might not be during their lifetime, but all those Nobel Prizes that people like Brian Schmidt won and all that, it means absolutely nothing, because we know they're wrong. Not just a little wrong. Not even in the ballpark wrong.
Paid by many a scientist with new and innovative ideas. Dr. Arp was forced to resign from his permanent position at the Carnegie Institute of Washington Observatories after the Caltech head of the Telescope Allocation Committee threatened him by saying, unless he changed his line of research, they would take away his telescope time. Due to this fact and his ongoing struggle against the established paradigms, Arp is often referred to as the modern Galileo.
I remember when I sent the paper into, the first paper into Astrophysical Journal on the nature of companion galaxies, and I had a lot of them on the ends of spiral arms, so I was sure that they were connected, and I showed that they were systematically redshifted. I sent that in with naive, great expectations that people would be terribly interested and impressed on this. And the editor of the Astrophysical Journal at that time was Subrahmanyan Chandrasekhar, who had a fantastic reputation as a master theoretician and also quite an incomprehensible theoretician, and a tremendously powerful figure in the field, and editor of the Astrophysical Journal, which is probably the most powerful position in the field. And he chose not to, in his wisdom and judicial fairness, chose not to send it to a referee, but he just wrote across the paper, "This exceeds my imagination," and he sent it back to the director of my institute, Horace Babcock, with the obvious implication, you've got to do something about this staff member of yours who's doing these very bad things. And so Horace called me down to the office one day after this, and I walked in his office, into the director's office, and I saw this paper lying in front of him with Chandrasekhar's scroll across it. And Horace looked at me and said, well, he said, this is just too much, and you're going to have to start looking for another job. And so all I could say to him was, well, if you send me that in writing. Please send me in writing. And I was waiting in great trepidation for weeks and months to get something in writing, and I finally never did, so I realized that he decided to give me another chance, so to speak. So that was fairly early in the game, and then some years went by, and there was the competition for time, particularly on the 200-inch telescope, was getting more and more heated, and people were saying, well, we can't continue to give time to this obviously incorrect and embarrassing research that ARP does. So finally they sent a letter to me from the allocation committee, including a number of the younger members of my institute, saying that unless I changed my line of research, that they would have to take away my telescope time. At that point, I considered the situation very carefully, and I figured that the evidence, although a lot more evidence could be gathered and has since been gathered since then, the important thing was not the evidence, because if it was true, it would come out someday. The important thing was the principle of scientific investigation, whether scientists could follow new lines of investigation and follow up on evidence which apparently contradicted the current theorems and the current paradigms. And I also felt that regardless of what happened to me personally, that this was the important issue, and that I had no choice but to resign on the point of this issue, so that if it developed, which I thought it would, that my line of investigation was correct, that people then in the future would say, okay, this was the wrong thing to do, and in the future we're going to have to see that this kind of thing doesn't happen again.
The observers come in now with the belief that we live in a Big Bang universe, and therefore all of their ways of understanding things are tailored to that. And they don't come in with the possibility that our alternative, or any other for that matter, is right, and really do it in an open-minded way. And of course what goes along with that is that observers who would like to test this way find it very hard to get observing time and so on. I mean, this relates to the whole issue of whether the complete lack of balance in the way the observational programs and the funding are conducted. There's no question about that. I don't think that anybody would argue about it.
If proto-quasars ejected from the nucleus of active galaxies themselves evolve into new, younger galaxies, astrophysicists must find experimentally and observationally the mechanisms which describe this phenomenon. One model explains that the proto-quasars are ejected, trapped in the galaxy's extreme magnetic field, aligned along the spiral arms, thus explaining the torn, disturbed features often observed in the galactic medium, and the frequent appearance of high redshift companion galaxies attached by filaments to a lower redshift parent galaxy. The other and most frequently observed alignment is when quasars appear to have been directly ejected out of the galaxy's active nucleus along its line of least resistance, creating a field of systematically high to low redshift quasars, or younger to older evolved protogalaxies. This is exemplified in innumerable systems like the one around the galaxy quasar field of NGC 3516. If one disregards the proposed redshift distance to these objects, observation clearly points to ejection as a likely explanation for their close vicinity to the central galaxies around which they are found. These results, though preliminary, are promising developments which may lead the way to new and exciting insights in cosmology.
One of the best and earliest of the really controversial things was a Seafoot galaxy known as NGC 4319, which Chip Arp discovered that it had
because I recently watched a very good, informative Don Scott lecture and took notes. The best way for me to be able to retain the information is to put it into a video. So I will paraphrase a brief summary of the history of plasma physics. According to Professor Don Scott, who we all respect for having a large wealth of knowledge in the electric universe, he says that the first plasma scientist, if you will, was Benjamin Franklin. He was also the first guy to insert a probe into a plasma. The probe was the kite, plasma was the sky. He actually did that. And I always thought that was an old wives' tale. Who would fly a kite in a thunderstorm? But he actually did do that. He's lucky he didn't get killed. But he was smart. He had the key in a jar, or so I think. He remarked that the sky is electric in 1752. Then, James Clerk Maxwell, with the help of Oliver Heaviside, one of my heroes that I've learned into math equations, he was able to put every electromagnetic effect into math equations, and thus electric theory was born. The next guy to come along is a name that we're all familiar with, Christian Birkeland. And Birkeland was the first person to suggest that the causation of the aurora borealis was coming from the sun. He was severely ridiculed for this by this guy Chapman, who was another one of those gas bags who believes in his own image. Chapman thought that the Earth was producing them completely within itself, and Birkeland was proven right at the beginning of the space age from a probe which found that the Sun and Earth are indeed connected. But you will get cosmologists even to this day who think it's not. Then in 1932, Irving Langmuir came along and noticed that plasma mimicked life, the blood cells, so he stole the name and gave it to plasma. American chemist Irving Langmuir. Today is Irving Langmuir's birthday, so it's a good time to remind ourselves of his very illuminating and timeless warning about pathological science. Langmuir was the first industrial scientist to win the Nobel Prize. The prize was awarded to him for pioneering contributions to surface chemistry, although he also did important research in electronics and solution chemistry. He did most of his work during the early part of the 20th century when science, especially physics and chemistry, was advancing at breakneck speed. Not surprisingly, when science advances at breakneck speed, so do its quacks. Langmuir took note of the many cases of fraudulent science published during the previous decades, and in 1953 gave a talk about the misuses of science, which he titled Pathological Science. His basic definition of pathological science was science which tricked people into believing false results by subjective effects, quantum, wishful thinking, and threshold interactions. Not all pathological science is willfully fraudulent, but all of it suffers from a common set of pitfalls that distinguish it from solid science. One can recognize how prescient Langmuir's talk was by the fact that many of the criteria we use today for evaluating scientific results or progress and identifying scientific misconduct are elaborations of his theses. Indeed. He knew. I bet he knew a lot of things, like the electric workings of the universe. I bet he had a good idea of it. Yeah, interesting that he would write that. I think maybe I'll do a video on him. He looks pretty like a pretty interesting guy. Moving on. You know, like all things that are covered up, there has to be a reason why they do it. You know, what does it mean that Standard Model is covering up the real deal in space? I'm sure it's for a reason. Did you know a magnetic field is more like a fog? Double layers are noisy. Name another name that should be recognizable to you. Hannes Alfvén. And with him, according to Professor Scott, Alfvén was an electrical engineer working for a Swedish power company. They were having these explosive disasters, and they tasked Alfvén to find out what it was. And he not only found out what it was, but he fixed the problem. It turned out that there was a capacitance going on, rather a plasma phenomenon. And every now and then it would explode in these high voltage DC direct current transmission lines. Alfvén deduced that these explosions were occurring in a double layer. So, as Professor Scott says, he extrapolated his ideas into the cosmos. And he reasoned out that this is exactly what is happening in something like a coronal mass ejection. Then Tony Peratt, who was able to create a spiral galaxy in a simulation in a supercomputer using nothing but plasma. And then last but not least, a fellow named Winston Bostick actually created a plasma structure that looked exactly